So this short video tutorial is over moles, and we're going to talk about moles of atoms, moles of molecules, and moles of units. So what is a mole? Well, just like we can say, we have a dozen donuts. A dozen means 12. A mole means 6.022 times 10 to the 23rd. And none of these exponents converted correctly with this program. So just know that 23 means 10 to the 23rd. And you're thinking, holy cow, that's a huge number. It is a huge number because atoms are so small, right? In science, we deal with a lot of small particles, whether it's a molecule or a molecule or an atom. We deal with lots of small particles, so we use these huge numbers, so they're easier to work with. So if we say we have a mole of carbon, that means we have 6.022 times 10 to the 23rd atoms of carbon, right? If we have 1 mole of sodium, we have 10.23, or 6.022 times 10 to the 23rd sodium atoms. 1 mole of gold is 6.022 times 10 to the 23rd atoms of gold. Okay, and you can see we could use these as conversion factors in our calculations using the factor label method. So for carbon, for example, we could say 1 mole of carbon is equal to, remember that conversion factors are always equalities, 6.022 times 10 to the 23rd atoms, right? And we can also flip that around. What if we're solving, instead of moles, we're solving for atoms? So we could also flip that around and say we have 6.022 times 10 to the 23rd carbon atoms over 1 mole of carbon. So these would be your conversion factors that you can use as a result of this quantity of the Avogadro's number. Okay, moving on. So we can also look at moles of a compound. And when we look at covalent compounds, so it's going to be a little bit different when we look at covalent compounds versus ionic compounds. Covalent compounds are called molecules. And so if we have 1 mole of carbon dioxide, right, 1 mole of carbon dioxide, that's 6.022 times 10 to the 23rd molecules of carbon dioxide. Or if we have 1 mole of water, right, at 6.022 times 10 to the 23rd molecules of water. And obviously these are also subscripts. Okay. If it's an ionic compound and we want to tell how many moles of that compound there is, we always use formula units. So, for example, NaCl, sodium chloride, is a ionic compound. So if we have 1 mole of sodium chloride, we say we have 6.022 times 10 to the 23rd formula units of sodium chloride. Okay, same thing for K2SO4, potassium sulfate, right? 6.022 times 10 to the 23rd. And I'm sorry that these didn't convert over from my Google Slides correctly. Hopefully you can see how these numbers should be subscripts and exponents up here. So anyway, so again, you can see how we can use this as a conversion factor. And so here's just a table that gives you some, just kind of an overview of the substances. So we have aluminum, which is a type of it's just an element. 1 mole of iron would be an element. So we can say we have 1 mole of aluminum would be 6.022 times 10 to the 23rd atoms. And then 1 mole of iron, which is an element, 6.022 times 10 to the 23rd atoms. And then here we have 2 covalent compounds, water and vitamin C. Both of those we refer to as molecules. And then 1 mole of sodium chloride are formula units of sodium chloride. But 1 mole of each of those is equal to 6.022 times 10 to the 23rd, whether it's atoms, molecules, or formula units. So like I said, we can use this as a conversion factor if we want to know how many atoms in a certain number of moles, or if we have a certain number of atoms, you know, how many moles are there in that number of atoms. So here's our conversion factor, right? 6.022 times 10 to the 23rd. And I did these before for you on the first slide. So we know that 1 mole is equal to this, so our equality can be used as a conversion factor, right? Always. So let's look at this one. It says how many copper atoms are in 0.5 moles of copper. And so we know that whenever we do any type of converting, we're always going to start with what we're given and then put it over 1. And so this is what we're given, 0.5 moles of copper. So we have 0.5 moles of copper, and we're going to put that over 1. And then we're going to multiply it by our conversion factor, right? Because we want to know how many atoms. So if we want to know how many atoms, we're going to put atoms on top and mole on the bottom. And if you remember, we know that there are 6.022 times 10 to the 23rd atoms per mole. And so that's what we're going to put here. 6.022 times 10 to the 23rd over 1. And so if we do the math, we're just multiplying 0.5 times 6.022 times 10 to the 23rd, and we would get 3.011 times 10 to the 23rd atoms, right, of copper. And so moles of copper, moles cancel, and we really should have put copper down here, and atoms of copper up here. So these cancel, and we are left with what we're looking for, right? Atoms of copper. That's what we're looking for. And here you can see that, and this should be moved up here, but moles of copper are canceled, and we have 3.0 times 10 to the 23rd, and they just dropped it off. I just typed this out in case you can't read my writing on the previous slide, but it looks like my lines are, this line shouldn't be here. Okay, so this should be 3.0 times 10 to the 23rd copper atoms. Okay? So here's another one. Here is an example of trying to find the moles of carbon dioxide that are in 2.5 times 10 to the 24th molecules of carbon dioxide. And so again, we're going to start with what we're given. And we are given 2.5 times 10 to the 24th molecules of CO2. That's what we're given. And so this is what we're going to start with. So 2.5 times 10 to the 24th molecules of CO2 over 1. And they want to know how many moles of CO2 are in that. So we're going to multiply, and since we're looking for moles is going to go on top. Moles of CO2. And molecules of CO2 on the bottom, because we want to end up with moles. So molecules of CO2. And so let's think, what is our conversion factor? We know that 1 mole of CO2 is equal to 6.022 times 10 to the 23rd molecules of CO2, right? And so what we're going to do this time is we're going to divide, right? Because we're going to be so we're looking for how many moles of CO2, and so that's what we have here. And we can see how molecules of CO2 cancel. And so that's a great way to check that you have the problem set up correctly. And so let's just go ahead and do the math. 2.50 times 10 to the 24th divided by 6.02 times 10 to the 23rd, sorry. So we can divide this part first. 2.5 divided by 6.2. I'm sorry, 6.02. And for that, we get 0.415, right? However, we also have to divide our exponents. And when you divide exponents, you're subtracting. So we take 24 minus 23. And that gives us 10 to the first power, right? 24 minus 23 gives us an exponent of 1. To write this in proper scientific notation, we're going to have to move this decimal point 1 to the right and write it this way, 4.15 times. Now, since we moved it to the right, instead of 10 to the first, what's it going to be? Right, so this is basically 10 to the 0. And 10 to the 0 just means that it's just 4.15. And we always need to put our units on our answer. This is the units we're looking for. This is the amount of moles of CO2. Okay? And you can see it here. We've canceled this and left with 4.15 moles of CO2. That's down here. We'll just cross that out. All right, and that's the presentation on Avogadro's number and moles.